In this slidecast, we'll talk about insertion sort. It's another quadratic sort, and it's based on a technique used by card players to arrange a hand of cards. So the player keeps the cards that have been picked up so far in sorted order, and when you pick up a new card, you make room for it and insert it in its proper place. Okay, that's insertion sort. So we start with a sorted subarray consisting only of the first element, and then we insert the second element either in the front of or behind the first element to produce a sorted subarray of 2. And we insert the third element in front of, between, or behind the first 2 elements. And we just continue that strategy until the array is sorted. So here's a trace of insertion sort. Consider this array, and in position 0, we can assume that 30 is in its proper place. And then for each array element from the second to the last, we insert that element where it belongs in the array, and we increase the length of the sorted subarray by 1 element. Now, to adapt the insertion algorithm to an array that is filled with data, we start with the sorted subarray consisting only of the first element. And then our next position is at 1, and we exchange so that 25 and 30 are in their proper order. Next, we'll consider the 15. We place it in its proper location so that the first 3 items are sorted. We continue with the 20. 20 should go between 15 and 25. And finally, we take 28, and that should go between 25 and 30. So that's kind of logically what happens so that we can sort an array using insertion sort. Let's look at it a little more refined to see what kind of information we need to keep track of in order to do this step by step. So again, we'll assume that 30 is in its is a sorted subarray of size 1, and we'll have a loop position to keep track of our for loop, and we'll save 2 variables, next position and next value. So we'll set next pos is the position of the element to insert. That's at 2. And then we'll save the value of the element to insert in next val. So we'll save 25. And then we'll enter this while loop. And while the next pos is greater than 0 and the element at next pos minus 1 is greater than next value, then we'll shift the elements at next pos minus 1 to position next pos. Basically, it's the idea of we're going to shift every element up until we reach the point where 25 needs to be inserted. So since we've saved 25, we'll see that 30 is greater than 25, so we'll move 30 to position 1, and now next pos is not greater than 0, so we'll go ahead and insert next value there. Alright, so now we get to the next loop position. So 15, that's the position where we're going to take that value and insert it where it belongs. So we'll save 15, and now in our while loop we'll move 30 up and we'll adjust 25 to its location, and now we're finally to the location where 15 gets inserted. Okay, so now the first 3 items of the array are sorted. Now our next position is at location 3. We'll save our 20, and now we'll go ahead and start adjusting again. 30 and 25 need to be adjusted. Since 15 is less than 20, we've reached the point where we insert 20. And we're now to the last position in the array. We'll save 28 to the side. We'll move down 30. 28 is greater than 25, so we'll insert 28 at position 3, and we're done. So the insertion step is performed n-1 times. And in the worst case, all the elements in the sorted subarray are compared to next value for each insertion. So the maximum number of comparisons is going to be this series, which is order n squared. Now in the best case, when the array is already sorted, there's only 1 comparison is required for every insert. So in the best case, the number of comparisons order n. And the number of shifts performed during an insertion is 1 less than the number of comparisons. So when the new value is the smallest so far, it's the same as the number of comparisons. So a shift and an insertion sort requires movement of only one item, while an exchange in a bubble or a selection sort involves a temporary item and the movement of three items. So a C++ array of objects containing the actual objects, and it is these actual objects that are changed. Here's some code for an insertion sort. So we have a template function that it takes kind of a first and last iterator, and then here's our for loop starting at first plus 1, working till the end of the array. Here's their insert function, and the code here in blue is the one which exchanges the pairs of values. So we've got a swap function here, and it's while next pos is not equal to first, and the value at next pos is less than next pos minus 1, that's where we have to do the swap. Now the following version of function insert follows the algorithm more closely, because this statement here declares a variable next val, and it stores the element referenced by next pos in it. And then the template class iterator traits is defined in a header iterator, and the value type represents the data type of the element referenced by the iterator next pos. So here's an insert method. We have the next value to insert. We'll do our adjusting, and then finally next val gets stored in its proper position. So this code here matches exactly what we saw in the diagram example that we just showed. So stop and study this code so that you understand what every statement does. And that's the end of this slidecast.